it will go for a non-ohmic conductor. The graph the V versus I graph, potential difference versus current graph, then the graph is a non-linear graph in which you will find out the resistances. The resistance are different values. The resistance values are different. Okay. Why it is different? Because of non-linear characteristics. Because of non-linear characteristics. Because of non-linear characteristics, the graph is a non-linear graph, so we will get different value of resistances. We will get different value of resistances. You will find the slope, then you will get the different value of resistances in this graph. That means the resistance is changing. That means the temperature is changing. Okay, when the temperature is changing, Ohm's law is not obeyed. That conductor is called non-ohmic conductor, and the characteristics is non-linear. For example, for all semiconductors like a diode, transistor, SCR, these are examples of non-ohmic conductor. The characteristic is non-linear. Okay, so this is the main thing about the Ohm's law. Next, we'll go for the factors affecting resistance. Factors affecting resistance of the conductor. Factors affecting resistance of the conductor. Number one, first is length of the conductor. Length of the conductor. L. The resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. When the length increases, the conductor length increases, resistance increases. When the length decreases, resistance decreases. Proportional, direct proportional. Okay, so resistance is direct proportional to length of the conductor. We will give it equation number 1. Number 2, area of cross section. Area of cross section. Area of cross section of the conductor. Or thickness. That is A. The resistance is inversely proportional to area of cross section or thickness. Resistance is inversely proportional to area of cross section of the conductor or thickness of the conductor. If the thickness is more, then resistance is low. If the thickness is less, the resistance is high. Okay, so resistance is inversely proportional to area of cross section of the conductor. These two mathematical relationship we are getting from these factors affecting resistance. Number 3, temperature of the conductor. Temperature of the conductor. With the increasing temperature, resistance increases. With the increasing temperature of the conductor, resistance increases. It is for conductor. It is for conductor. With the increasing temperature of the conductor, the resistance increases. With the decreasing temperature, resistance decreases. This happens only for the conductor. If you go for the semiconductor, you will go for the semiconductor. You will go for the semiconductor. With the increase in temperature, the resistance decreases, and with the decrease in temperature, resistance increases. For semiconductor, this condition is for semiconductor. So, in case of semiconductor, Ohm's law is not obeyed, and if you go for the conductor, Ohm's law is obeyed, but temperature condition remains constant. Temperature remains constant for obeying the Ohm's law. So, if for a semiconductor, that with the increase in temperature, resistance decreases. With the increased temperature, resistance increases, but not proportional. Not proportional. It is not proportional. We will not get any mathematical relationship, proportional relationship will be between the temperature and resistance. Number 4. The fourth factor is nature of the conductor. Nature of the material. Nature of the material of the conductor. Nature of the material of the conductor. We know that if the conductor is a good conductor, of course low resistance. Good conductor offers low resistance. Good conductor offers low resistance. And bad conductor offers high resistance. Bad conductor offers high resistance. Okay. If the conductor is a good conductor, the resistance is low. If the conductor is a bad conductor, the resistance is high. Okay. So good conductor offers low resistance, bad conductor offers high resistance. You will go for a classification. The best conductor is silver. Then it is copper. Then aluminum. Then iron. Then lead. The silver is the best conductor. You will go for the copper. The next to silver is copper. The next to copper is aluminum. Iron and lead, they are used for making fuse wire. Copper is using the wiring purpose. Silver is very much costly, so you cannot use for the wiring purpose in the homes. So we are using mostly copper. And copper has low resistance. It's a good conductor having low resistance. Okay. So these are the 4 factors which are affecting resistance of the conductor. We are getting 2 mathematical relationships. One is resistance directly proportional to length of the conductor. Then resistance is inversely proportional to area of cross section of the conductor. We will take these 2 relationships. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of cross section of the conductor. This combining equation 1 and 2. Combining equation 1 and 2. If you combine the equation 1 and 2, R is proportional to L by A. Then R is equal to rho L by A. R is equal to rho L by A. So rho is the specific resistance. Specific resistance or resistivity of the material of the conductor. Material of the conductor. It is the specific resistance or resistivity of the material of the conductor. Okay. Depends upon the material. So you will go for this rho. The rho is equal to RA by L. The unit of resistivity is ohm meter. SI unit is ohm meter. It does not depend upon the dimension of the conductor. Does not depend on does not depend on A and L. It is independent. Independent of A and L. It does not depend upon the thickness or length of the conductor. Okay? So it is independent of area of cross section and length of the conductor. Okay? So this is all about this Ohm's law and factors affecting resistance of the conductor. And next class we will discuss about details about the resistivity or specific resistance. Thank you.